Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 and now we are going to present about our project still. So first of all, for our project overview for this project, group members have decided to choose covered court as the main design for the stadium requirement. So the reason as to why the design of the covered court is chosen is because it has great example of steel structures that consist of multiple parts of building that can be, as we can see here from the picture, the design is inspired by basketball court. So for the design concept, the length of the whole court is 28 meters and it is divided into 5 sections. Each of the sections are divided by steel column. The height of the court from top to bottom is 11.2 meter. The height of each of the column is 6.8 meter. The width of the court based on the front view is 18 meters. So for the truss design that our group has chosen is the PRAD truss. This is because it can lowering the self-weight, lowering the cost of the building due to more effective members, and making the structure easier to construct. As we can see here, this is the example of PRAD truss that our group have built and chosen. So that's all from me. Thank you.
Hello, Assalamualaikum. My name is Hakim and I will present about the determination of the internal force. So let's go to the next slide. This the figure show is our method for this project. And the next slide is about the data output from the step pro, which from the top chord, and this is from the bottom chord. And this is data output from the step pro, which vertical member, and this is from the diagonal members. And the figure show is about the data output from the step pro for the axial force for data for, and this is for compression and tension for our column. So we get the compression which is axial force 18.89 and 124.43. And last not at least, this is a self property for main truss and column. So the self for the column we use UC 360 times 400 times 634. For the size for top and bottom chord is UC 200 times 200 times 16, and the size for internal members is UC 100 times 100 times 10. And that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rahman and now I'm going to present about the chapter 4 and 5 for this project. So let's proceed. So for the chapter 4, we pick one example of our manual calculation for the tension and compression. So for the first of all, for the tension, we choose member 1709 as the example. So as we can see here, the NED and versus NERD value is 0.67, which is less than 1.0, which is okay. So for the compression member, we choose member 1673 as an example with the load for 1398 kilonewton. So for the section classification, the value of section classification is 0.82, which is less than 1.0, which means it is okay and acceptable. And for the buckling resistance also, the value is 0.98, which is less than 1.0, which is acceptable. So I'm going to proceed about the chapter 5 for our project. So for the chapter 5 is design of a connection. So as we can see here, the load for one angle section is 81.6 kilonewton, and for the throat thickness is 42 mm. So for the design shear strength of well, you can see that the value is 222.7, or can be used as 223 Newton per millimeter square. For the design resistance and total resistance, as you can see here, the value that we use is 0.94 kilonewton over millimeter. And for the total resistance, as we can see here, we use 86.8 millimeter. Total of required length, we use 111 millimeter. And the total resistance of well is we use as 104.34 kilonewton. So therefore, the 104 kilonewton is more than 81.6 kilonewton. So we use 104 kilonewton. So for the well arrangement, as we can see here, the length of the well is 58.6 millimeter. We have to add 25, which is 2 minus 6, which will become 12 millimeter. For the required length is 70.6 mm, so we use 71 mm. The other side length is 28.2 mm. At 35 to multiple by 6 mm. So for the required length is 40.2 mm, and we use 40 mm. So that's all from me. Thank you.